Module 5, Section 2, Maintenance Best Practices. Ongoing monitoring and support is very important to guarantee the correct functionality of your chain. One way to achieve this is through telemetry. The Cosmos SDK has a telemetry packages that enables operators and developers to gain insight into the performance and behavior of the application. This is enabled in the app.tom config file and in the config.tom file. There are two available telemetry sinks, one is in memory and the other is Prometheus. The Cosmos SDK comes with some predefined metrics for the application layer, and the Comet BFT comes with predefined metrics for consensus and networking layers. Additionally, developers can add the desired metrics to custom modules and application. So we can go to the docs for the Cosmos SDK and you will see a section for telemetry where we have all the list of the supported metrics by default. As you can see, we have quite a few of them for the different modules. And also in the Tendermint documentation, that it's the now called Comet BFT, there are also some default metrics related to networking and consensus. You can check what's the consensus height, information about the validators, if there are missing blocks for a specific validator or a missing validator, and many other information about also P2P peers and the mempool size. We can look into this in our node. I added to our settings.json one more endpoint for the Comet BFT metrics. This is going to give us the consensus and networking metrics. And then from our application API that's in port 1317, we're going to get our metrics. I added this metrics.http. So to get the Comet BFT metrics is just pointing to the corresponding endpoint and going to the path /metrics. And for the application one, it's using the base URL, that's the API /metrics. But to be able to use this, we have to enable this in our node configuration. So let's go to RPSD, to the config directory. Let's open this in our IDE so we can work properly. So in the application, first you will have to enable the API that by default is disabled. So we can set true. And then we have to look for telemetry. And here we can enable it by passing this flag to true. This will enable the application telemetry, all the metrics for the application layer. And then for the consensus one, we have this instrumentation where we set the Prometheus to be true. And that will do. We can close this now. And we can start our chain again. And we will have these endpoints enabled. So we can send a request and you will get all the available metrics that we saw previously. Comet BFT for different timing connections and block intervals and time for different timing for the different rounds. There are quite a few here that you can use to build your monitoring dashboards. And on the application side, we have this format of metrics. We have some gauges, some information about the memory allocation as well, the Golang application, and then we have some information about the modules. If you remember, we defined in our RPS module an end blocker, but as you can see, the label is not properly set. This should be an end blocker. But here you can have information and of the custom metrics that you added. Let's fix our metrics. So if you remember, we added this telemetry module measured since, and as you can see, we are using a key begin blocker, but this is an end blocker, so let's change it and fix this. So we can restart this, install the changes, make install. So now our metric label is going to be fixed. And we'll start again. And let's try it one more. And if we look here, now we have our end blocker properly set for our module. Feel free to go through the documentation of SDK and add all the metrics that you want to see in your module. Another useful tool for monitoring our chain are indexers. The indexers extracts transaction data from a blockchain node and loads it into a database or another service for easy querying. The common use cases of an indexer are for data access, query performance, data analytics, and development. In every Cosmos SDK application, we have an indexer that we can enable. If we go to the config file in our RPSD config, you will see that in our config toml we have a configuration for an indexer that's going to it's going to be our transaction indexer, and here you can set which database you want to store the transaction information. You can select a key value store that will default to LevelDB, and also you can set to be PostgreSQL. But usually indexers are looking into blockchain events and indexing as a separate process of the blockchain. But anyways, Cosmos SDK allows developers to have an indexer built in the chain binary. Regarding support for a blockchain project, the communication channels used are usually GitHub, where the source code of the project sits, and we can follow up all the updates and releases. Discord, Slack, and Telegram are used for communication within the team and the community, and a bug bounty program or a vulnerability disclosure procedure is usually set in different websites or in the repository itself. Regarding handling updates and patches, there are a couple of options. Usually you can set up a dependabot that generates automated dependency updates. That's what we have in our repository. If you go to the RPS chain, you will see that at the moment we have some pull requests to update some dependencies. This is quite useful because you don't have to go yourself and look into what dependency of yours have a new release. So this will open up here automatically, and you'll have to review and merge this. But for key dependencies, the dependabot sometimes is tricky. For example, Cosmos SDK and Comet BFT dependencies sometimes have new releases that are backwards incompatible, and we have to look into this if we have to update other dependencies. So for Cosmos SDK and Comet BFT, it's recommended to go through their docs or on the repo also, where we will have some guides to migrate from different versions. For example, when migrating from Cosmos SDK B047 to B50, it's quite a big change. So we'll find in the repository how to migrate from those versions to the new one. And regarding how to handle Security vulnerabilities, you can use the GitHub Security Advisory. This you can find it in the repository. You'll have to have administration permissions, and within the security tag, you'll find here the advisories. And you can create a new security advisory. And what this does is creating a fork of your repo, but it's going to be a private fork where you can safely discuss and fix the vulnerability. The procedure is to create a security advisory and then merge it to the corresponding branch and make the new release. And after this, you can publish the advisory so everybody knows which version is affected and which are the versions that are patched. And this is all for Module 5. Let's recap.